Okay, so this is another example here. A piece falls off a rocket that is 27 meters above the ground when the rocket's moving upward at 21 meters per second. Neglect air friction. What is the velocity of impact of the piece with the ground? What time does the piece take to reach the ground? And then to what height does the piece rise above its release point before coming down? So let's draw a little picture here. I think we've got the ground here, right? And this rocket is 27 meters above the ground, right? Let's draw our little rocket here, right? And some piece is going to fall off of it, so let's make it the fin, right? Hopefully the rocket does okay, right? Not looking good for it, right? I think what's happening here is that this piece is moving upward at 21 meters per second, right? And then this is 27 meters above the ground. So I think the piece is going to continue going up like that, and then it's going to go down and strike the ground, okay? And so I think 1 and 2 here, we can actually solve by going from here to here. Okay, so we're going to go from this point to this point, okay? And what we do is we just set this thing up. We go x, v initial, v final, acceleration and time. And our displacement from here to here is that we're going to go down 27 meters, right? Now remember, it's the change in position, not the distance it goes. The distance will be more than 27 meters because it's going to go up and down, but our formulas don't deal with distance, they deal with displacement. I think our initial velocity is positive 21. Right? Our final is we don't know. Our acceleration is negative 9.8. And then the time is we don't know. Right? So we're being asked for the final velocity and the time. Okay? Now, to solve this with the formula x equals vi t plus 1/2 at squared, okay? To solve that would be quadratic because we know x, we know vi, we know a. And to solve for t would be quadratic. We'd get two roots, a -1 and a +1. And we would take the positive one. Let's suppose we don't like the quadratic equation. Let me suggest something else that we can do, right? We can use this guy, right? We can use no t to find vf. So vf squared is vi squared plus 2ax, right? So vf squared is 21 squared plus 2 times negative 9.8 times negative 27. Okay? Well, that's just going to be the final velocity will be the square root of this, right? And then that's going to be the square root of vf squared is actually the absolute value of vf, right? Okay? So let's do this. I'm going to go second square root, left parenthesis, 21 squared plus 2 times negative 9.8 times negative 27, right parenthesis, and I get that the absolute value of the final velocity is 31.14. Okay? 31.14 meters per second. Now, that means it could be positive 31.14 or negative 31.14. I'm going to choose that it's negative. So the final velocity is negative 31.14 meters per second. Okay? I'm choosing negative because I think it's going down when it hits the ground. You can choose either one, okay, but I'm going to choose negative. And then to find the time it takes to reach the ground, I'll then use VF is VI plus AT, right? So negative 31.14 equals 21 plus negative 9.8 times whatever the time is, right? Okay, so let's figure this out. Put the 21 on the other side, and you get negative, what, 52.14 or something like that, right? And then divide by negative 9.8. And you get 5.32 seconds. Okay? And so we've answered these questions. The velocity of impact is down 31.14, and this is very close, right? I might have used 9.81 or something for that, which is a little more accurate. The time is 5.32 seconds. And then to what height does the piece rise above its release point before coming down? We'll have to do another one. We'll have to go from here to here. Okay. Now, sadly, I've got to erase all of this nice stuff there. So here goes. Ooh, it's gone. Right. So now we're going to solve this problem, right? Which is, here's the rocket. The piece goes up. It goes down. We're going to solve from here to here. Right. And now we know that we don't know x, right? We don't know what this x is. We know the initial velocity is 21, positive, right? The final at the top is 0, right? The acceleration is negative 9.8 meters per second squared. And I'm going to choose the f squared is vi squared plus 2ax. And I'm going to solve for x, right? So 0 squared is 21 squared plus 2 times negative 9.8 times x, right? So 21 squared divided by 2 divided by 9.8 is 22.5. Ta-da. So whenever you change the first part of the problem, 1 and 2 went from here to here, okay? This problem goes from here to here. Whenever you do that, you've got to do this whole thing again. Anytime you change the time interval, you've got to set this whole thing up again.